Here we will try to combine our knowledge till this point. Before watching this video, it's recommended for you to watch the lectures here, lecture 1.3 for the max code, lecture 2.1 for the modular or hierarchical implementation, or lecture 1.2 for bus declaration. Here we have two 1-bit multiplexers. One of them is called high and the other one is called low here. By combining them, we will try to implement 2-bit multiplexer. So for that purpose, we have here 1-bit multiplexer code from lecture 1.3, and I will use that code here in this video. And I will divide my circuit here like this: block 1, block 2 and main block. So here I will call inputs of the sub blocks small a, b, s and c. Again a, b, s and c. Then after I define my main block and set it as a top module, I will combine the inputs of the main block with the inputs of the sub blocks and output of the main block with the output of the sub blocks. So let's start. This was a multiplexer code that you can remember from lecture 1.3, and this was the diagram of this was the circuit of the multiplexer, and these are the labeled wires here. Here I should generate my main block. I will add a design source here. It's not a simulation source, it should be design source. Add and create file here. File name is main block, and click on OK and finish. For the main block, I have here two inputs A and B. They have 2 bits, A and B, and set is 1 bit here. Input, cell, select port, and output is again 2 bits. It's called out. Here I will call multiplexer with a name high firstly. So I should multiplexer by writing max the name high, as you can see here, this one, and point A, input of multiplexer, should be connected to A1, and then point B to B1, and S to the cell, point S, cell, and finally output of the multiplexer, which is C, to the output of the main block, like this. Then I will call again multiplexer, but this time give another name referring to this block, block 2 here, this which is low here. So I will do the same thing, just copy paste, but this time least significant bit of A and B, set is the same, the out is 0 here. So that's okay. Vivado automatically set the main block as a top module here, as you can see. So we can write a test bench code. Test bench should be like this, and you should connect this input and this output. Input should be rec format. Select is 1 bit. And output should be wire, again 2 bit. And main block is unit under test. A with ATB, B with BTB, and cell with cell TB, and finally out with out TB here. Initial, begin and end, and give different values to the inputs. Here I give A is equal to 2-bit binary 0 0 and B is 2-bit binary 0 0 and select port is 0. I will give another input values here. Let it be 0 1 and this is 1 0, for example. Let us make them different here, and let's just copy and paste and change the values. It is first 2, and let's make here select port is 1 and this is 1 1 and 0 0, and this again 1 and this is 0 1 and 1 1, for example. You can give different values. Let's run the simulation. As you can see here, when select is 0, for example here, output is same as B. Here B is 0 and output is 0, and B is 2 and output is 2. And after 20 nanoseconds, select port is 1, and after that time, output is same as A. A is 3 here and out is 3, and A is 1 here and output is 1.